All right, good morning, everyone. Today's Friday, September the 24th. Happy Friday. We have our 2.03 day number. Sorry, this is 2.05 day one, I believe. Yeah, 2.05 day one. All right, so I will be absent on Monday, so I'm going to record the lesson we would have on Monday later this afternoon, probably around noon. If you can make the live session, if you want to, you don't have to, you can. But on Monday, if you don't, you don't show up or watch the second, the 2.5 day two at noonish, just on Monday, when we don't actually have the live class, just go ahead and watch the recording then. It's up to you. But then I'll be back on Tuesday. Also, so kind of give you a recap of what's going to happen next week. So we're going to have on Tuesday next week, we will have the third day of 2.05. Then on Wednesday, we will have the review for Unit 2. Thursday, you will do part 1 of the exam for Unit 2. And then Friday, you will use that time to do part 2 of the exam. And then, looking further ahead, then the following week, the week after next, we will be doing the midterm. Yes, we're already at the midterm point almost. So Monday, October 4th, we'll have the review of the midterm that day, and we will also have to do the test that day, because then on Tuesday, October 5th, we're starting Unit 3. Halfway point. Can you believe it? We're almost halfway over. Can you believe it? Okay, so this was given yesterday into the end of the hour to do as basically homework, right? This is semesters. We have this is like, I guess, the summer term, and then we have what do they call it, the spring term or something, January. Yeah, we're not doing trimesters. All right, so does anybody have an answer? So what is your final answer? Or let me see what the answer even looks like. Hang on a second. Yeah, so what did you get? So what's the element in row 1, column 1 for your final answer? Anybody have that? What is A sub 1, 1? Or in this case, H sub 1, 1? So it looks like Noah says -8/3. Ooh, so Ryan, I'm going to pick on you. So he wrote -2 2/3. Hang on, let me. So I'm glad you brought this up, because you're not the only one to make this mistake. All right. Now I did state this like the very first week of pre-calc, but I didn't actually write anything down. So Ryan said -2 and 2. Oops. -2 and 2/3. All right. All right. What kind of fraction is that, class? Yeah, that's a mixed fraction. And do we do mixed fractions in pre-calc? Yeah, absolutely not, unless otherwise stated. There might be a time when we will use them, such as a word problem, maybe. Yeah, we don't do mixed fractions in pre-calc. The only time you can do a mixed fraction is in life is like if you're cooking or baking, right? So if like directions said, all right, we need 2 2/3 cups of flour, that makes sense, right? 2 2/3 cups of flour. So, in that situation, which is not pre-calc, it's okay to use mixed fractions. But, we either do simplified proper fractions or simplified improper fractions. So the improper form would be, now hopefully you remember in grade school if you had a good teacher, right? You go counterclockwise, right? So you multiply, right? And then going here, you add. Is that new to anybody? I'm really curious. Because honestly, your teacher should have taught that. Is that new to anybody seeing that? Okay. Because if you said yes, you probably had a terrible teacher in grade school. And I don't know. I don't want to know who it is. I'm not going to put anybody on blast other than you were done injustice math wise. All right. So improper fraction, 2 times 3 is 6, and then 6 plus 2 is 8. So this is negative 8 thirds, which is, I think, what Noah said. Yeah, guys, so on your quizzes, on your tests, do not use mixed fractions. You will get it wrong. I had somebody message me this morning about that, saying, is this not right? And if they're here, I'm not going to say who it was. They're not here, which is fine. So yeah, anyway. So yeah, the element one, or sorry, row one, column one element is negative 8 thirds. Let's take a look at the actual work. So people who are actually able to finish this or tried it, was this problem a lot easier than you thought it was going to be? Yeah. Noah, would you like to take Mike and kind of walk me through, the first part of what you did? Yeah, please do, on the mic, please.
All right. So the first thing that I did was look at the first set of matrices, and I saw that that matrix with 3, -2, 7, and 4, they're the same on both sides. So that means they're being multiplied by the same number. So I set 3 halves times m equal to 2, and then solved for the variable m to get that variable.
Good. Everyone understand that? So looking at this, remember yesterday I said this problem looks a lot harder than it really is. And, Noah said it perfectly. I couldn't have said it better myself. All right, Noah, keep going. Take me through the next half.
All right, so then as we look at the second matrix or set of matrices, we can see that H is the same as the matrix on the right, -2, 5, and 8, because they're set equal to each other and the parentheses just moved. So that's the associative property. So yeah, matrix H is -2, 5, and 8. Do I keep going or? Okay. And then to solve this, just multiply matrix H by 4/3, and that's how you get the answer.
Beautiful. Thank you. So yeah, if you try to work through this, you would have saw that it's actually a rather easy problem once you actually see it and heard Noah's explanation. Nice job. Thank you. Yeah, it's easy if you don't make the simple mistakes, right? True. Yeah, good point, Brady. And then, of course, we could have, for 4/3, we could have plugged that into here to make sure that it worked, which it does, right? 3/2 times 4/3 gives us 2, so that's good. And then for this, we could have plugged in this answer. Well, no, we actually couldn't plug this in. We could have plugged in H, right? We could have plugged in H to make sure it works, which obviously it does. But, pretty much from this point on, you have to have multiplied 4/3 times every element to get the right answer, right? So you will get fractions. All right, let's go. Let's go today's lesson. 2.05, determinant of a matrix. This is that matrix. Okay, I need to, my spelling not so good. I will fix that later. All right, paper, pencil, pen, calculator. So super easy stuff. I think you'll like today's lesson. It's my spelling mistake. All right, so what is a determinant? So a determinant is a scalar value. Remember, a scalar value is just a number. It's a real number, right, other than zero. So scalar value determined from a square matrix. So a square matrix has to have the same rows and same columns. Like, I guess a 1 by 1 is considered a square matrix, I think. But anyway, 2 by 2 would be a square matrix, a 3 by 3, a 4 by 4. Those are all square matrices. So it is highly useful value in higher mathematics. Determinants are used in computerized graphic creation as well as applications of calculus, physics, and engineering principles. In this class, the determinant of a matrix will be used to solve a system of linear equations. So we're going to use a determinant value, which you're going to, we're going to see exactly what that is. But remember, it's just a real number. We're going to use that determinant to solve a system of equations. So like two equations, right? Two unknowns, solving for x and y. Also in this class, I want to note, if I don't already have it on the next page, which I don't. Okay, so when we do the determinant and it says a square matrix, we can find the determinant of a 3 by 3, but for simplicity's sake, for this pre-calc class in high school, we are only going to focus on 2 by 2 matrices and their determinant. We will not be doing a determinant of a 3 by 3. It's very different, but if you take, a class in college on matrices, you will learn how to do a 3 by 3 determinant matrix. The class in college, if you want to take a matrix, so they actually offer an entire course on matrices. That class is called linear algebra. And it's crazy to think that you can spend 4 months learning about matrices, but you can. Okay, let's see what a determinant really is. So determinant of a 2 by 2 matrix. All right. So we're going to multiply the top left entry by the bottom right entry. We're going to call that step, well, we'll call it A. So looking at, this matrix here, this matrix, we have the elements A, B, C, D. So we're going to multiply top left times the bottom right. So A times D. So make sure you write this down in your notes. So A times D. Next, step 2, we multiply the top right entry by the bottom left entry. So B times C. So far, pretty easy, right? Then we subtract the A value minus the B value. So AD minus BC. And then you have your determinant. Piece of cake, right? Mm-hmm. Yeah, super simple, right? And that's it. Yeah, that's exactly how you find the determinant. Also, so notation. When you see these absolute value bars around your matrix variable, so this is matrix M, these vertical lines do not mean absolute value when they are around a matrix variable. It means determinant. So whenever you see the absolute value bars, this means find the determinant of M. So when you see this notation, you should know immediately, all right, we're going to do A times D minus B times C. So this is right here, I guess, the formula, if you like formulas. But you should have this memorized. you do a few, it's super easy. A times D minus B times C. So we should all save that to memory. Yeah. All right, so now let's actually apply it. So we now know how to find the determinant. Now let's actually use it. Well, let's find it on these, and then we're actually going to apply it to solving equations. So quickly, I'd like everyone to solve these 4 examples for matrix A, B, C, and D. I would like you to find the determinant of those values. I think giving you, 2 minutes is plenty of time, right? Probably more than enough. Where'd you go? Okay, so first one, A. What is the actual math operation that we do before getting the answer? Two. Well, the entire thing? So 2 times 1 is um, so 2 times 1 minus 5 times negative 5. And then what is the answer? What is the determinant of A? Negative 23? Everyone agree? No? Grady says negative 27. Anybody else? We got another negative 23. More negative 23s. Looks like mostly people saying negative 23. So we got 2 times 1 is 2 minus negative 5 times negative 5 is positive 25. And then 2 minus 25 is negative 23. Yeah, I agree with that. Yeah, make sure you show your work. Like maybe instead of writing what I just wrote, maybe you actually write 2 times 1 minus negative 5 times negative 5. Hopefully everyone in this class at this point in your math career, you should be not making the negative mistakes. Like negative times a negative is positive, times a negative is negative again. So if you're still making this, you need to show more work so you don't make it. Okay. All right. What's the answer to determinant of B? 7? Okay. Oops, that's not my. All right. What's the determinant of C? You got a -8, more -8s. So a lot of you put -8s. So I don't have the answers in front of me, and I will believe you if you tell me this. However, I look at this and I don't believe you. So let's actually show the work. And if you're doing these in your head, maybe you shouldn't. Maybe you should write them out because simple mistakes. So we're going to have, remember, this is 3 times 0 minus -4 times 2. All right. Do you want to change your answers now? So Naomi says just 8. Noah says 8. Anybody else want to agree with that? Yep, it's 8. It's 8. Yeah, 3 times 0 is 0, right? And then we have -4 times 2 is -8, right? And then we're going to have 2 negatives, make it a positive. And we all know that 0 plus 8 is just 8. So yeah, the determinant of C is just 8. So make sure you show your work. It'd be terrible if all of you actually knew how to do pre-calc math, but you fail this class because you can't do 8th grade math, right? You need to know how to do basic math very well to do well in this class. So you can know everything, but miss everything because you're skipping steps, not showing your work, making very simple mistakes, and it's just costing you. I have a lot of people who email me or message me and they show me screenshots of their work, and I look at it and I'm like, you know what you're doing. Like, you understand the concept just fine, except you're making some simple mistakes by just not showing your work. You're skipping steps. You're doing stuff in your head because you think you're doing it right, but you're not. So yeah, guys, just be safer than sorry. Show more work on your paper to ensure success. Okay. All right, and then what's the determinant of D? So we got a bunch of positive 11s. So I believe it to be also positive 11. Yeah, so if you did not get positive 11, double check your work. And if you didn't show work, make sure you do. So I'll show this work for this one. It's like some of you got something else other than 11. You can't believe you missed it. Yes, the answer is 11. So even the best of us, not saying that Noah is the best of us. Maybe he is, I don't know. But we all make mistakes. I'm surprised I haven't made any more on my actual lessons. So let me just show it real quick. So we got -1 times 5. And then don't forget it's minus, right? Minus, and then we have -4 times 4. So maybe it's that middle minus, right? So let's go back to this formula again. So remember, it's subtraction. So it's always subtraction in the middle, and maybe that's what's throwing you off. Maybe you're just adding them. So make sure you have that written down in your notes correctly. But yeah, it's don't forget that subtraction. It's always gonna be a minus sign right there when doing determinant. All right, -1 times 5 is -5. And then we have a negative times a positive makes it a positive. So we got, at 16, right? And then 16 minus 5 is 11, or -5 plus 16 is 11, right? Okay. All right, other than the simple, tiny mistakes that some of us are making, we feel good about doing determinants? All right, good, good. And hopefully, a good thing about coming to live lessons and making mistakes is you get to see that you get to show yourself that, hey, maybe I should show more work, right? We always learn from our mistakes. I'm a huge believer in that. Failing is important, so we learn what not to do. All right, so we're gonna actually apply it now, called Cramer's rule. And you can actually look if you're curious and you want to see more, I guess, bigger, more complicated examples. You can always search like YouTube or something and watch videos of more complicated examples. But like I said, we are only going to use a 2x2 determinant matrix. So you will only apply Cramer's rule to a system of equation that has 2 equations and 2 unknowns. So in this case, x and y. All right, so write this down. This is just the formula we're going to talk about. We have, a sub 1, b sub 1. These are just coefficients. Your c sub 1, c sub 2, those are constants. So, just a number. A sub 2, b sub 2, again, those are just coefficients. So we need 3 things. So let me jump to, let's see. We need 3 things. We need to determine the determinant of this matrix. We also need the determinant. So it's d sub x, determinant of x, and then we need the determinant of y. So these are the 3 things that we need to solve for our system of equations. And I think, once you learn this, you'll probably never want to solve 2 equations, 2 variables again using substitution or elimination or graphing, because this method is so fast once you do a few and you learn it. So the determinant has a lot of uses. Like I said at the very beginning, and the use that we're going to use it for is to apply it to solve for systems of equations using Cramer's rule. So it doesn't just do one thing. It has a purpose for many things. Okay, so let's actually see the math. All right, so the determinant, all we're going to do to find just regular D determinant is we're going to set up our matrix with just the coefficients of x and y. So that's why I have a sub 1, b sub 1, a sub 2, b sub 2. So yeah, it's like we're creating the augmented matrix without the constants, right? We just drop these. Okay, so in chat, what is the determinant going to be equal to based on what I showed here? What do we get? A sub 1 times b sub 2 minus a sub 2. Well, basically, yes. So just your order was wrong. It wasn't wrong. It's just not the order that was given in the original formula. So remember, it's top left times bottom right minus top right minus bottom left. Obviously, if you switch these two or you switch these two, it's the same thing, right? But this is the standard formula. Top left times bottom right minus top right minus bottom left. So yeah. Next, the determinant of x. All right, so this is the tricky one. It's going to take some practice. So for d sub x, it's still going to be a 2 by 2 matrix. Now, because it's d sub x, remember, so this is your x column, right? Column 1 is x column. Column 2 would be your y column. If we had a third column, if it was an augmented matrix, we would have the constant column, right? So that should be familiar from earlier this week. So because we're doing d sub x, your x column becomes your two constants. And then you can probably guess when we're doing our d sub y, determinant of the y, your y column becomes your constants. So I'm going to just uncover those. All right. Everyone awake and clear and heard me on that? All right, going on to the other two. Other than that, these are just going to be whatever you see here. So, this is still your y column, but because it's d sub x, we just put your y coefficients. And then for d sub y, we only had to replace your y column with the constants. Your x column will still be the x coefficients. I don't expect anybody to memorize this exactly. You just need to have it in front of you so you know which to put. The only way you're really going to miss these problems is if you really copy the matrices wrong, right? And then, yeah, so still, C1 times B2 minus B1 times C2, and there's that. All right, once you have those three things, once you have determinant, d sub x, and d sub y, once you have these three things, we can now solve for x and y. Super easy. So the x solution is going to be equal to d sub x divided by d. Your y answer is going to be d sub y divided by d. And that's it. And you have your answer. All right, let's take a look at an example. And by the way, so on the right here, this is just your formulas, right? I'm just having this for reference, especially if you didn't copy it down fast enough. You can copy it down now. All right. You're given this problem here, these two equations, and we are to solve for x and y. We need three things. We need determinant d sub x and d sub y. So determinant d, determinant d sub x, determinant d sub y. So I want everyone to go ahead, don't solve anything yet. I want you to set up all three matrices. So let's so set up your D matrix, set up your D sub X matrix, and then set up your D sub Y matrix. So let me give all of you, I think a minute to just set them up is hopefully enough. Ready to go. 1 minute to set them up. All right, our first matrix. Did we all set it up correctly? Good. All right, our d sub x, determinant of d sub x. Did we all set it up correctly? And our d sub y determinant. Did we all set it up correctly? Okay, good. Okay. Determinant. So let's go ahead and quickly solve this first one. We'll do it together. So we do 5 times negative 5 is negative 25, and then minus, right? Don't forget the minus. 4 times 1 is 4. And then negative 25 minus 4 is negative 29. All right, we're going to solve d sub x. So we get 25 minus negative 4 gives us positive 29. And then determinant d sub y, negative 5 minus negative 5 equals 0. So let's ask this. Well, actually, I told you. Okay, sorry. I meant to give you time to do these. Yeah, don't respond. That's my fault. I'm rushing ahead. All right. So everyone can hopefully see the work and understand, and you would have got the same answer. So let me ask you this question. If I gave you time to solve those 3 determinants, you think you would have gotten all 3 of those answers? A lot of you say yes, some of you say maybe. All right, fair enough. And there's still one of you that is here, but not here. So lights are on, nobody's home. All right. Now let's actually find the answers. So we have the 3 determinants that we need. So let's go ahead and solve this. The x value, what number goes on top? 29. And what goes on bottom? Negative 29. Yeah. And so what's the answer? What does x equal? Negative 1. Yep. Y. So what goes on top? 0. And then on bottom is negative 29. And so what's the answer for y? 0. Yeah. So the answer is an ordered pair form at negative 1 comma 0. How can we verify that we got the right answer? Yeah, you just plug it in, right? We plug it in to make sure it works. Another way we could have solved this is by graphing, I think in Desmos, you can just type it in exactly. You type in both equations and you see where they intersect, and they will intersect at negative 1 comma 0. That's another way to check, is just by graphing instead of plugging it in. It works, yeah. So that's Cramer's rule. So to recap, you need 3 determinant values. You need determinant d sub x, and determinant d sub y. Once you have those 3 values, it's as easy as taking your d sub x divided by d and your d sub y divided by d. It is that easy. The only hard part is setting them up, because it's easy to pull out the wrong values looking at this, because there's a lot going on here. So I don't blame you if you happen to copy the wrong stuff, right? But if you know that your determinant matrix is just the coefficients, right? 5, 1, 4, negative 5, top to bottom. And then your d sub x, because we're talking about d sub x, your x column gets replaced with your constants. your y column doesn't change. So we have 4 and -5. And then your determinant d sub y, your y column changes to the constants and your x column does not change. So we just pull out the 5 and 1. So if you remember that, that's, in my opinion, knowing that is much easier than trying to look back and forth at the formula to kind of pull out, right? To pull out what we want. I think looking at this and relying purely on this, you're going to make mistakes if you don't actually know what you're doing. I don't know. This is my opinion. So what happens if you end up with division by 0? That's a good question. So that would be impossible. Well, hold on. Yeah, that would be impossible. Well, it's not impossible. It's impossible for me to give you a problem like that because in order for dividing by 0 to occur, we would have to have, like in the first equation, we would need one of your equations to be 0x and 0y. Or the x would have to be 0 coefficient and this y would have to be a 0 coefficient. But if I gave you a 0x here and a 0y, you would only have y equals some number and x equals some number. So you wouldn't even have to use Cramer's rule. So it's not impossible to get a 0 determinant, but to apply it to solve an equations, it's impossible because that would just be foolish. There'd be no point. Hopefully that makes sense. So in other words, you should never divide by 0. If you do, something's wrong. And you should probably, if you can't figure it out, probably ask me what's wrong. All right, everyone, let's try this one. So let's do this. I'm going to give you, let's do 3 minutes. I think 3 minutes should be enough to solve this problem start to finish if you don't waste time and tab out to go on your Instagram or whatever you're doing right now, or some of you are doing. All right, make sure you're tabbed in, do this problem. I see a lot of you tabbed out, not doing anything. So, guys, if some of you get randomly kicked out of the new row, just come back in. I kick you out because I think you're not here. Like I'm seeing this, the icon showing that you're actually not in classroom, and I just boot you out because I think you're not here. But if that does happen to you by mistake, just join right back up. Ooh, someone almost got kicked. Okay, time is up. So let me ask you this. Give me a happy face if you were able to finish and get X and Y. And middle face if you're close. All right. So people who are still working, how much time do you think you need on it? There's a few of you. All right, no needs more time apparently. All right, everyone who is able to finish, what did you get for your solution for? Actually, give me the answer in ordered pair form. 5,5. Ooh, lots of 5,5s. Let's take a look. Yeah, 5,5. Brady, don't forget parentheses. So like on a TGA, if I asked for like ordered pair, ordered triplet, and you gave me like 5,5 without parentheses, I'm gonna mark it wrong because that's not an ordered pair form. You couldn't use your other hand. This is assuming you have two hands. Sorry if that's insensitive. Oh, drinking water. Okay, there you go. All right, let's take a look at the work. Let's see. So yeah, I think everyone. It seemed like everyone who responded got it right. So nice job, everyone. The math is really simple, right? The setup is really simple, but there's so much room for error. All right. How's everyone feeling about using Cramer's rule? Good. So what time we got? We got 6 minutes. All right, good. Let's do one more example. Let me give you like 3 or 4 minutes. So go ahead and do this one. Ready, go. All right, let's do this. So hopefully everyone should be done by now. I gave you well over 4 minutes. What did you get for your answer? Your ordered pair? 3, -4. A lot of 3, -4s. Anybody else? Lots of 3, -4s. Let's take a look. You know, and I'm making the assumption that people who got the answer, they plugged it back in to verify that it works. But yeah, 3, -4. Let's take a look at the work, and then we will call it a day because it looks like we're running out of time right now. Let's see. So blast through these. All right. So how's everyone feeling about using Cramer's rule? Pretty nice, right? Yeah, it's pretty good. So we all know we can solve a systems of equation using substitution method, elimination method, graphing method, reduced row echelon form method, Cramer's rule. Anything else I missed? I think, yeah. So we know we can solve a problem 5 different ways. All right. All right. Well, nice job, everyone. Everyone looks like they're feeling good about Cramer's rule. As always, thanks for coming, and I hope you learned something. I will see you all maybe this afternoon. If not, I'll see you all Tuesday.